Well, hi and welcome to my shop, and thanks so much for joining me here as I'm just getting a start on this little Northern Electric radio here. Today is April 26th. Not a particularly sunny day here. So if this is the first time you've watched one of my videos, I just want to tell you that this really isn't an instructional video so much as it's just me working away doing my thing here in my shop. So certainly you can learn some stuff from me. I take the time to explain some things that I'm coming across. Of course, it's my explanation. It could be wrong. Other times I'm just working away, not explaining in any great detail what's up. So I've done quite a few of these little radios. This is called the Baby Champ. Very popular radio when it was on the market, I think in the late 1950s. I think had one of these in my house when I was a kid. This was the radio that was on my parents' dresser. Not this particular radio, but one identical to it. This one has come to me from a retail store that resells things like this and other antique sort of things and that. And so I don't know anything about this radio other than here it is on my bench. So we're starting right from scratch here. And talking about scratch, let's start with that. On these radios, what's very common is for this plastic window to be smashed. This one's not. This one's in very good shape. It looks to me like it's nice and clear. It's actually really quite nice. The cabinet itself is in better than average condition. And just looking at how much reflection there is on the top here. It's a Bakelite radio, a classic brown Bakelite radio. And you can see how shiny the top is. Now when you clean these things, if you do anything aggressive to them, you start to remove the nice shine. So by the time these radios get to 2020, a lot of them are kind of, they've lost the nice sheen, but this one hasn't. So he's a little exceptional. Now unfortunately, a little bit of damage has happened here. Obviously that corner is knocked out on it. It has a large crack extending all the way to here and then fading out. This is going to be a growing crack here. So we're going to want to try to do something to stabilize this so it doesn't continue, but I don't have any. I personally don't try filling these kinds of gaps. You know, you can do it with body filler, but you'd be on your way to repainting the whole radio. I'm not about to do that. So the knobs on the front look rather peculiar to me, and these are not the proper knobs at all. This one has a mark on it. It's just a tuning knob. It shouldn't have a indicator, so not the right knobs. We're going to pop them off. I probably have much more suitable knobs than those. Okay, we'll take a look at the back. What do we got here? Sold May 1st, 19... Oh my gosh, does that say 53? 1953, I think that's what that says. Right there. There's the Baby Champ symbol. Some kind of a sticker on here. Oh my gosh, there's my cat Shadow, anxious to go out. Here's a note here. Take a closer look at this note and see if we can read what's written there. There's the serial number written in by hand, 00634. 634, that's a pretty low number. Oh my gosh, my cat. Oh, one of these things these cats know is how to be persistent. Yes. What? Can you be more specific about what you want? What is it? Okay, in cat language, what do you want to do? What do you want me to do? Oh, that stumped her. She's not sure how to answer that question. You've only got one answer anyway. Why don't you use it? There it is. So, unfortunately, the cats have realized now it is spring, and they can go out. So I think that's what she's saying. I think she's saying out. So I have to stop and go deal with her. Oh, jeepers. Well, we're not going to hear from that cat for a while. She's stuck in the garage now. Yeah. Okay, so we're looking at the back of the radio here. Some interesting notes, and we're going to take a closer look with a different camera. See what we can see here. So there's the sold May 1st. So that's got to be 53 there. RB. Which is kind of odd. That's an odd note. RB. Why would somebody... Okay. That is a more interesting note here. So it looks like 9th of January 1965. I'd say it says condensers. $5.50. Yeah, I think that's what that says. While we're looking right here at the cord, let's look at the cord. So I'm pretty sure this is a replacement cord here. Let's just take a look at how they did the... And this is done correctly. Very good. That's a good one. Okay. Some more notes here. The Model 5000. Made in Canada. Yeah, there's the handwritten serial number. Made in Montreal. Don't you dare operate this thing without a license from the King. His Majesty. There's the tube lineup. 35 Z5, 35L6, 12, 12, 12. Licensed by the Hazeltine Corporation only for the use in homes, for educational purposes, and for private, non-commercial use. You're not supposed to have this playing in your restaurant, this radio. Radio patents. Okay. And then there's this. Oh, another written note there. What's that say? 3540. And there's this sticker which is missing now. Sticker went right up on the side of the cabinet. It's a piece of tape. Somebody put a piece of tape on here and then wrote on it. Wrote on it and the writing is gone. It looks like a label. There's the baby champ. There he is. The baby champ. Oh, many more notes here. June 26, 1953. New tubes. $1.50. June 26th. New tubes. May. Wait a minute. Sold it in May and put new tubes in it in June. Okay, that's a little hard to understand. Serviced. Oh, so here's the guy who did it. They peeled off the last service sticker and stuck his on. Serviced by Irving's. 1015 Kingston Road. Now you're going to fall out of your tree, but I lived on Kingston Road for quite a few years in Toronto. I lived at 426 Kingston Road, so this was serviced. You know, I can kind of picture where this was, just down the road from me. Way back when. See his phone number there? Looks like it says QX. Probably says something like QX1 3829. When I was a kid, my phone number was Logan 3 7653. Go ahead and dial it. Yeah, okay, that's enough staring at the back. I don't think there's too much more to... You know, I like to get a feel for the story behind these radios. They have a story. This radio's had a life. It's been places. It's seen things. It's done stuff. It's had associations with different owners. Who knows what the story is behind this guy? I know this part of the story here in my shop. Now let's take a look at getting him out of the cabinet. I don't think there's any bottom screws in here. Just these two holding in screws. I think these screws, I think these are holding the back to the radio. It's these 4 corner screws that would come out, and then the whole radio drops out. The radio should be ready to come out right now. Why didn't it come out? It was stuck. That's why. Okay, not much holding that radio in there. That's for sure. Exactly what was holding it in there? You know, it's just these knobs. Just these knobs were holding it in. Okay, let's take a quick peek inside the cabinet. Occasionally there's something exciting going on in here. Looking for labels. Also looking for a bar of gold. I'm still looking for that bar of gold. Not going to show up in this radio, I'm afraid. There's the plastic window. Beautiful. Okay, I'll put the cabinet off to the side. Now we'll take a look at the radio itself. So right away I see it has all of its tubes, which is good. The speaker has a huge tear right through it here. Really looks like a finger punch. So that has to be fixed for sure. The light here is knocked out of its place. Loosen its holder. So it's taken a knock. So this guy's been shoved around a bit. This is kind of roughed up this little bit here. Maybe it got, I don't know, shoved around a bit. I don't know. So I've done quite a few of these radios. I don't ever remember seeing a plate like this. So this is just a little bit different than the last one. It's interesting. Fairly clean. Okay, nothing more to see down here. Let's flip it up. Look at how clean this is, actually. This is fantastic. Here we go. What's happening underneath? Ah! Oh, okay. Well, mostly original. Clearly this guy's been added in with all of his wire. Oh, is this tape or what is this? What is this? This is another one. Oh, look how they've done this. Oh boy, this is a bit of a sloppy job here. How come this one's here too? They got this. They got this. They got this. This is a 40. And it looks like this one's still hooked up. Oh my gosh, this is the can't say I've ever seen so much capacitor shoved into a radio like that. So the question I'm asking myself while I'm looking at this is this too dangerous to turn on? Can we turn this guy on? This doesn't look original. This on-off switch and volume control. Could be, just doesn't look that way to me. There's a big high wattage resistor. It looks like it's been a little warm. Anything look burned or terrible shape, fluid dripping out of things or anything like that? No, not really. So these connections are fairly well insulated. There's nothing sticking out here, so I don't think it's unsafe to try and operate it. I would just leave it on its side though. I don't think I want to flip it down. So again, if this is the first time you're watching one of my videos, my shop is outfitted with a few features to make this work safe and doable. One of them is I have a way of supplying 120 volt, of supplying power to the radio, so that if there's a serious problem in a radio, it won't pop my home circuit breaker or set a fire or anything like that. And the way I do it, it's a very common thing called a dim bulb system. I invite you to Google that, dim bulb protection or something of that sort. Here's my dim bulbs right here. Yeah, only this one is screwed in right now. The other one is loose in its socket. This outlet that I'm plugging the piece of work into is fed by a transformer. This doesn't go straight into the wall and off to the nuclear power plant. This goes through a transformer just under my bench here. That provides isolation to the workpiece and means the chances of me getting a shock from the piece to earth is greatly reduced until I take certain steps in my shop, and then the fact that I'm using an isolation transformer doesn't mean much at all after once I get going here. So what I'm trying to say to you is, if you're new to this and you're watching this video and you've never seen some of my videos, you might not realize that there are steps being taken to keep me safe while I'm doing this work. So I'm just sort of alluding to a couple of them. So I'll be able to power this guy up, and all the electricity that gets to this outlet passes through this light bulb on the way. If there's a big short circuit in here, the light bulb will simply come on really bright, and I'll know. And if there isn't a short circuit, then the light will come on a little bit probably, and we'll probably hear something come out of the radio. Who knows what? Let's get the volume control under control. So first I turn this off and just check. Yeah, tuning will tune. So with the set off, of course, the light bulb should not light. I'm now going to power this up. Okay, so no light on the radio, no light up here. The radio's turned off, so no current can flow. That proves the on-off switch at least turns off. So I'm going to cut the power now. Oh, you can actually read this little box here will tell you the voltage and a few other things to tell you the power that's being drawn and things like that. That's quite interesting. 123 volts today. Power off. Switch on. This time it's really important to really watch this light. I keep my hand on the switch up here. If the light comes on really bright, it'll be off right away. Second thing is, the light doesn't indicate a big short circuit. The radio itself may hum crazily or do something like that. Power off again. So here we go. The volume is turned down. Watch for the light. There we go. Okay, so no light. Power is 113 here. That means there's a draw and there's a voltage drop in the bulb, which means the radio is coming on. No hum yet. I'm trying to get a look at the tube so I can see one tube lit. If one tube is lit, they're all lit. They're all heating. This got so many capacitors in it, it better not hum. Volume's turned down, so I'm not expecting too much. Gotta be patient here while they warm up. Supply voltage is 115. Power being consumed by this guy is 20 watts. 21 volt amps. Oh, silent. I don't hear any hum or anything. Let's turn them up now. I think we know why it's silent. Oh, oh. Okay, we got up to full volume. We got something. Wow, just happened to be tuned. So it's an extremely insensitive radio here. Oh, it's just lucky I happened to be on that spot. Very, very insensitive radio. No hum whatsoever. So it's interesting. Kind of working. Poor sensitivity. Poor volume. Maybe it's just volume. Maybe it's really, no output volume. I'd like to set the radio down flat again. Just a little nervous about all those capacitors in there. Let me do that. Power off, just to be a little bit extra safe. As long as I'm running the electricity through the dim bulb light bulb, it's a little like having a fuse there. Not really, but if I were to create a short circuit doing something like I'm doing now, the light would just come on really bright. Just leave those in there like that. Oh my gosh, and that's just a horror story. That's a horror story. There's all kinds of stuff with black electrical tape on it in here. Okay. Okay, power it back on. Watching the light. This didn't come on. Oh yeah, that's right. This light isn't coming on. Probably burned out. So one of the problems in these radios being the 5-tube transformerless radios. There's no power transformer in this radio. You look at it all day, you'll never find one. There isn't one. So without a transformer, they have a couple of challenges. One is to, how do you supply these 12-volt tubes when the only voltage easily available is 120 volts? So you put the tubes in series, and then because of the particular tubes that have been selected, they all operate properly with the same current. I think it's, don't quote me, I think it's 150 milliamps of current flowing through each tube, and then different tubes have different voltage drops. Like the 35W4 is dropping 35 of the 120 volts. If you add up 35, 35, that's 70, 12, 12, 12, that's 36, 70 and 36 is 106. Uh-oh, that's just a little short, isn't it? That's a little short of 120. So there might be a dropping resistor in here. Just notice this tube is floating pretty high in the chassis. Why would that be? I'm going to turn the radio off. Got the power in it. Push the tube down. Pretty sure it was making connections there, but let's just be doubly sure. Is that why the radio was quiet? I think the answer is no. Can you hear it? Just a little hiss. You probably can't hear that on the video. Okay. Well, I think probably with this radio, the first thing to do is to test the tubes before doing anything anymore. I think that's the smart move. Power off. Good. Good so far. The main thing you don't want to find out with a radio like this is that one of the coils in the radio is damaged or burned out. And one of the easiest ways to find that out quickly is to get the radio operating to any degree, like we just had today. Making a little bit of hiss is very reassuring that there isn't one of these terminal problems in a radio like this. Coils that are in these cans could develop an open circuit, and then it's really problematic to repair a radio if something inside here is defective. It'll have some coils, should have at least one coil underneath here somewhere. There's one here. That's the only one, I think. So again, if this has been damaged, it's really tough to fix the radio. Otherwise, just about everything else can be dealt with. Okay, I'm going to lay it flat again because I'm going to do the tubes here. Put your guts back in. Your guts are falling out, man. The entrails. The radio with entrails. Okay, I'm going to stop for a couple minutes, get the tube tester set up, and we'll run through these tubes and see what we find out. When I'm testing tubes, one of the things I like to do is make absolutely sure the tube is what it's supposed to be. So this is supposed to be a 35W5. What was it? the back of the radio here. Just to be sure, 35Z5. Okay, so this should be a 35Z5. Philips, made in Canada. Sometimes they stick it up on the top here. There's some writing up there. The trick is to get the light to shine off it just right. Plus I'm doing this in a camera, which means, oh, there's a 5. Doing it in a camera, which means things don't move necessarily. Well, I see the 5. Trying to get the focus right. By the way, this is easily done with eyeballs. Not so easily done on camera. There's the 5 again. There's the Z. And we're going to guess that the 35 is there. But actually I don't have to guess because I can see it with my own eyeballs here. So okay, that's definitely a 35Z5. Okay. 35Z5. So, I 35Z5. Z5. Okay, 35 volts on the filament. It's a rectifier, so a number of settings are not made. 07003. 07003. 0610. 0610. 23. E for the plate setting. So up here on the dial, you probably can't read it, but there's a spot that says rectifier is okay if you're above this line, about halfway. Get above halfway, rectifier is okay. Plug this guy in. Switch on the tube tester. So the very first test on this tube will be for short circuits. Rotate this knob and you watch the pointer and see if it comes up any significant distance. No. So there's no shorts internally to the tube. Now you want to flip this test switch that says rectifier and diodes here. And watch the pointer at least come up past halfway. Here we go. Way up into the OK area. Great. Now is there another set of plates or anything? Nope, that's it. That's the entire test. It's a winner. I'm not too surprised. Just turn down the filament voltage. Put that back in the radio. We'll pull out the output tube. Now this one, $50L6. A 50L6. Okay, wait a second now. I've been through this once already with this kind of radio. So it's made, the schematic where the tube lineup, it's definitely a 50L6. The tube lineup will call for a 35L6, wasn't it? What was it? 35L6, but instead there's a 50 in there. Now if you add 50, 35, 12, 12, 12, you'd get right up around 120. It actually makes more sense to have this in there. But there must have been a dropping resistor in the circuit. If you put a 35L6 in there, you got to get rid of 15 volts somewhere. Okay, this isn't the first radio, first of these like this, so I will carry on as if everything's normal. 50, when I test it as a 50, of course. 50. Oh, that's not 50. I'm having trouble seeing my own thing here. 50, there it is, 50L6. Okay, 47 filament volts. Signal level 8, that's a high test signal. 18H, the bias is fairly high also. 18H. 07345. 07345. 0610. 0610. 43. Make the meter make sense. Plate is C. So in this case, we want the test result to be just above 1,000. 1,000 is right here. Okay. Let's put it in. Warm up. Do the short test. No shorts. And GM test up above the 1,000. Oh, what happened there? Okay, so what happened there? I don't know why it went up and dropped right off. Nothing to do with the tube though. So it's above 1,000. So you wouldn't really be suspicious that this tube is the reason why the radio's quiet. Okay, so let's go to the next tube. 12 SQ7. Put that guy back in. 12 SQ7. No doubt about that being the 12 SQ7. And that's definitely what's being asked for here, is it not? Yeah, Q. So A7, K7, and Q7. Q7. Okay. 12. So that's okay. Just want to be careful with the filament voltage that you don't leave it high by accident. 12 SQ7. 12S. There it is. 12 SQ7. Filament set to 13, which it is. Signal level 1. 18L, so a lower bias. 25100. 25100. 3760. 3760. Sensitivity is 37. Plate is F. Recheck point is 760, so down here. Can you see that? Can't really read it. There's a 50 written right by my finger there. It's got to get up above that 50. Around that number 50 is actually 75 on the correct scale. 760 on the correct scale. Okay. Okay. Oh, I got to put the tube in. We're not going to get too far with the tube. Okay. Do the short test. Nothing. Okay, just double checking 760. Where are you? Way above 760. Way, way, way above 760. Now there's a second test for this tube. It's a diode test. So in this case, we want to switch the numbers to 2013P. I'm going to pull the tube up while we do that. 2013P and 0760. 0760. Okay, 48 sensitivity. And switch this to a different plate. P1 and P2. So there's a button here, plate 1, plate 2. So on this tester, you set these up, and then if there's two plates, you just have a plate switch. Quite handy. If we're on the diode, diode's okay is way down here. As long as the meter gets up above this spot, we're good. Tube in. I'll repeat the short test. Why not? Okay. P1 rectifier diode test switch just above here. Just above the marking. P2 slightly higher, but they're both okay. So this is not going to be the guy causing us trouble. No, this is not going to be the one. If there is a tube. If there is a tube that's weak. And there we go. Now, next tube. Next tube is so these green insulated wires are often really stiff, and the insulation just cracks off them if you move them any distance. This one's right above the tube here. Let's see if I can preserve it. Probably not. I think it's a two-hander. Get a screwdriver through there. Kinda. Okay, get the tube out. There it is. Didn't have to move the green wire at all. And the tube is the SK, 12SK. 12 SK. Oh, yeah, that's right. Things are running backwards here. SK7, there it is. Signal level 2. Bias 10L, L10L. GPK53. GPK53. G. Uh-oh, wrong tube. Wrong tube. Back up. 17251. 17251. 4630. 4630. Sensitivity 44. C. Oops. C. 1520. Should be just about straight up here. Now, secretly, I am hoping one of these tubes will show up really weak, and we'll put a new one in, and bingo, the radio will be working with full volume. That's what I'm secretly hoping. Okay, shorts. No shorts on the tube. 12SK7, straight up on the meter. It's more than straight up on the meter. So very good. It's a very good one. Okay, we're running out of tubes here to blame the problems on. So I'm just gonna get the next tube out. 12 SA7, that's correct. 12 SA7. 13 2 9L 2 7 3 4 5 2 7 3 4 5 1650 1 6 5 0 sensitivity 45 C 12 SA7. Yeah. Whole tube in a single test. 1100 is the reject point. Go. So this is the first tube in the radio. The antenna is connected to a grid on this tube. Local oscillator is connected to a grid on this tube. And then this tube's job is to mix those signals and produce, if things are correct, produce a 455 kilohertz signal. When I say if things are correct, it means if you've actually tuned in a station. Actually, it takes more explanation than I can afford to give right now. But this is a very important tube. They all are, in fact. Okay, so the GM for this guy should be 1100. Just above the 1000 mark here. Hey. Oh! I think it's my switch is giving out here. It's still rising, it's still warming up. But it's way higher than the reject point. So what I've discovered here is all the tubes in this radio are in good shape. I cannot blame anything on the tubes at this point. Unfortunately, there has to be another cause for the weakness in this radio. Okay, a little surprised actually. I kind of thought maybe we'd hit the mark. Now there are radios that I repair in my shop. I never ever do test the tubes, believe it or not. You know, I suppose it should be a routine matter to always test the tubes, but I don't in some cases. The radio's working so well, the tubes must be good. So what to do about this? Well, there's a bunch of molded capacitors here which are known for being unreliable. There's a wax one here. There's all this stuff hanging here. There's no hum in this radio, but really, who can be surprised? Look at how much capacitors are in here. I could remove all this and replace it with just a couple of nice small ones. Get rid of most of this. There's probably two. Yeah, it's probably just paralleled all this in with the original one. They're all paralleled in. No, it looks like he's cut the terminal there. He's left the ground terminal here. Yeah, that's what he's done. He's done the terminal cut. So the technique this guy's used to remove the original capacitor from the circuit is to reach in there with a strong pair of cutters and cut the terminals and leave the wires bundled up on the now cut off terminals to have a connection point. He's then added in these guys. This one he's made connections, well, he's one connection's here with the tape. That's really crummy. And the other one, he's gone and found a spot over here to solder it. Solder it on. Yeah, I think my best move is to get, even though it's not humming, is to get rid of these guys. 75 volts, 4040. This is 100, what'd I say? 175 volts. Yeah, 150 volts, 4040. And then this is probably not going to be able to read it. Can't read it, but we can guess it's probably a 4040 also. And then this one is probably to bypass the cathode resistor on the output tube. I can't be sure what this is doing here. what is it? It's a 200 volt, 200 surge volts, 150 working volts, 40. It's another 40. That's a lot. That's a lot, but look, I mean, look at it. I can take all that out and just turn it into little tiny capacitors. And I have a pile of them, so why don't so I'll do that for sure. Get all this nonsense out of here. I mean, how can I work on the rest of the radio with all this stuff hanging out here? Like a doctor. We must cut away his intestines. I can't see what I'm doing here. Good. That's the plan of action, but I think that'll be tomorrow's video. I'll go to work on this thing tomorrow. Try to resolve all the capacitor issues tomorrow, and then see what we got for a radio at that point. Sounds like a good idea. Okay, so thanks a lot for watching, and enjoy your day as much as you can.